Sketching polynomials is a key thing you have to be able to do at higher. Now, polynomials, remember, are functions that go up in powers of x, so x cubed, x to the power 4, etc. And we have to be able to sketch these accurately given the information that we're given in the equation. To do this, what we're going to do in this video is we're going to refresh our memory of what we have to do when we sketch a quadratic. Now, this is a skill we covered in National 5. However, it's a relevant skill and definitely a vital one that we should go over and just refresh our memory of. Now, when we're sketching a quadratic, there's three key bits of information that we have to be able to calculate in order to sketch it accurately. The first of these is the y-intercept. Now, if you think about when you're sketching a quadratic just in general, it looks something like that. The y-intercept is where it cuts the y-axis. So that point there on the y-axis where the graph cuts it. Now, if you look up and down the y-axis where it meets, there's something you should know about any point on the y-axis. Up and down there, at any point, the value of x is equal to 0. To get the y-intercept, that means that we have to substitute x equal to 0 into the equation of our quadratic. We then want to look at the x-intercepts and see what they are. Now, these have a special name that you'll see written down an awful lot. These are what are called the roots of the function. Now, if we again imagine we've got a general quadratic, and it looks like that, there's our roots, there's our x-intercepts, there's where it cuts the x-axis. Now again, calculating these is one key thing you need to remember about all the way along the x-axis. And what that is that y equals 0. So in this case, what we do is we set y equal to 0. Once we've done that, we then solve the equation and we find out our points where it cuts the x-intercept, so we find our roots. Once we've got the roots, we can then get the third key bit of information, and that's the turning point. So that's this point here, where the graph turns back on itself. Now, you'll get one of two types for this. So every quadratic will have one of two types. They'll either have a maximum turning point, so a highest point on the graph where it turns and comes back down on itself, or a minimum turning point, where it looks like that, it's got a lowest point, and it turns back up onto itself. Now, to get the to get the coordinate of these, we need the roots to be able to do that. Because it's quite straightforward when we're doing it. What we have to do to get the x part is we take the two roots, so let's imagine these are called x1 and x2. We add them and we divide it by 2. So we find the midway point of these two roots, and that will tell us whereabouts in the x-axis this lies. Then to get the y part of it, we take this and substitute it into the equation to get y. That will give us the coordinate of our turning point and where we need to go for that. Now, the best way to illustrate all of these points in action is with a couple of examples. So here we go. Let's imagine I give you y equals x squared plus 8x plus 7, and I want you to sketch that graph right there. Well, first thing we have to do is get our three key bits of information. So the first key bit of information was our y-intercept. And to do this, we have to remember that x equals 0. So substituting x equals 0, and we get 0 to the power of 2, plus 8 times 0, plus 7. Well, 0 squared is nothing, 8 times 0 is nothing, y equals 7. So it cuts the axis at y equals 7, so our y-intercept is given by the coordinate 0, 7. Second thing we then have to do is calculate our x-intercept, so where it cuts the x-axis. And to do this, we set y equal to 0. Substitute that in here and then solve it and we'll be fine. So let's do that. So we then get x squared plus 8x plus 7 equals 0, and we've got to solve it. Now remember, to solve a quadratic like this, we factorise. We think of our three types. Common factor? No, there's not one. Difference to two squares? No, it's not that format. It's a trinomial. Solve the trinomial and we get x plus 7, x plus 1 equals 0. And then we get our two solutions from the bracket. So the first bracket tells me that x equals negative 7, and the second bracket tells me that x equals negative 1. So there you go, I've got my two intercepts there on the y-axis, I've got my two roots. Now as you're going, it might actually be useful for you to build this information up onto a diagram. You're able to mark all this on as we go. So imagine we do that. Y equals 7, so we know it's going to cut here at 7. My two roots, negative 7 and negative 1. So there's my negative 7 there. There's my negative 1 there. That's me got my two roots. The only thing I need to do now is my third key bit of information, which is my turning point. Now, to do that, we find the middle of the two x parts, and then we substitute it into the original equation. So I know to do that, I've got negative 7 plus negative 1 divided by 2. Negative 7 plus negative 1, plus minus becomes a minus, so it's negative 7 take away 1. So that gives me negative 8 over 2, which is negative 4. So the x part of my turning point is negative 4. To get the y, we substitute that into the equation. So I know it's going to be negative 4 squared plus 8 times negative 4 plus 7. Negative 4 squared gives me 16. 8 times negative 4 gives me negative 32. And then plus 7 on the end. So 16 take away 32 is minus 16. Plus 7, we're at negative 9. So I then can say, fine, so my turning point is at negative 4, comma negative 9. And I can mark that a bit of information on about there. So there's negative 4, negative 9. Now we just double check. I've got my roots, got my y-intercept, I've got my turning point. I can sketch the curve. So you sketch it coming down this way, going up that way, and up and through there. Now, as you can see, the 100% accuracy of the diagram is not vital, but it still has to have the same general shape with this right information marked onto it. And that right there is how we sketch the curve of this quadratic. Let's look at another example just to illustrate this again and just confirm this 100%. Imagine I've got the equation y equals x squared minus 4x plus 3. And I wanted to sketch that. Well, again, we need to calculate our three key bits of information. So first one, the y-intercepts. We set x equal to 0. So we get y equals 0 squared, take away 4 times 0, plus 3. So I get y equal to 3. So I know it's going to cut at the point 0, comma 3. So again, if I wanted to, I could build this up gradually as I'm going. So imagine we draw a set of axes. There's my x-axis and my y-axis. I know it's going to cut there at 3. Second bit of information is my roots. So for that, I know I set y equal to 0. So I've got x squared, take away 4x plus 3 equals 0. And I've got to solve this. So factorise this side. X minus 3, x minus 1 equals 0. So from this, I could say x equals 1 and x equals 3. So I know that's where it's going to cut the x-axis, and I can mark that on. So there's 1, there's my 3. Final bit of information was my turning point, how I calculate that. Well, in order to do that, the first thing I have to do is find the midpoint of my x's. So add the two of them up, 1 plus 3, and divide it by 2. What that gives me is that x equals 2. Now that we've got the x, what we want is the y. Well, we know y equals x squared minus 4x plus 3, and we know what x is equal to 2, so we substitute in for the y. So what that does is that y equals, well, x squared is 2, so it's 2 squared, take away 4 times 2, plus 3. Then it's a case of solving these. So 2 squared is 4, take away 4 times 2 is 8, plus 3, so that is equal to negative 1. So my point is 2, comma negative 1. So I can mark that on, so it's there. 2, comma negative 1. So now, at this point, I can look and say, right, do I have enough information? Well, I've got the x ones, I've got the y-axis, and I've got my turning point. Now that I've got that, I can just draw it up. So I can make it coming down this way, back up to there, and then off. And then call it its name. So it's y equals x squared minus 4x plus 3. Doing that gives me the drawing. When we're doing a sketch of it, that's what we have to remember we have to do. We have to remember those three bits of information we do. So we want the x equals, the y equals, and the turning point, and we want to get those bits of information and use them to sketch and draw the graph.